So this is 1.7b in college algebra on page 149, bottom of the page. We're going to continue on, and we're going to first of all talk about even and odd functions. Okay, really not too much of this, as you can see, just it's just not much there as far as examples or explanations. So we'll see if we can make some sense of this. This seems to be a tricky one for some students, but let's see if we can make it easy. It says in the bottom of page 149, if the graph of a function f is symmetric with respect to the y-axis. So for example, if we have something that is symmetric with respect to the y-axis, we say that it is an even function. Okay? So that's an even function if it's symmetric with respect to the y-axis. If it is symmetric with respect to the origin, we say that it is an odd function. So an odd function would be, like I've shown before, like a square. If we can take this thing in this direction or the other direction, 180 degrees, and it ends up laying on top of each other perfectly, then it's symmetric around the origin. And therefore it's odd. Okay, so those are the only two we deal with, because if it is symmetric with the x-axis, then we've got a little bit of a problem here, because it's going to be, and I'll do this in red. This is symmetric with the x-axis, right? Well, the problem is it's not a function. You do the vertical line test and you go through 2 points on that graph, which makes it not a function. So that's why we don't deal with going across the x-axis, or the x-axis, just the y and just the origin. Alright, so let's just do the even function first. And what it says is if we take the function of our graph, and if it's the function of negative x, if those two are equal, then it is symmetric with respect to the y-axis, and it's an even function. So when you're given an equation, f of x equals something, and you plug in a negative x for that x, and you still get the same thing, then it is an even function. So let's see if we can find one here to try. They give us example 3, so let's just look at that one real quick. So there's our h of x. Now if this is an even function, if we take h to the negative x, and every time we see an x, we put in a negative x, and if we get this back when we're done simplifying it, then it is an even function. So let's keep going here. So 5 negative x to the 6th power gives me an x to the 6th, minus 3 negative x squared is going to give me a squared, and then we're going to subtract 7. So that is equal to that. So h to the x power equals h to the negative x power, just like we said right there. So therefore it is an even function. Okay, so that's an example of how to figure out if it's an even function. Now let's look at an odd function. So the rule to determine whether it's an odd function means that f of negative x equals negative f of x, and that's on the bottom of page 149. If that's a true statement, then it's an odd function. So let's look at this one example that I have listed right here, and we'll see if that's an odd function or not. So the first step is to find f of negative x, because what we're given is f of x. So we're going to have to find f of negative x and then compare it to negative f of x. Okay? And negative f of x, all that is this with parentheses and a negative in front of it, and then we distribute that negative and see if it works. So let's go ahead and find f of negative x first. So f of negative x equals 5 times negative x to the 7th minus 6 negative x cubed minus 2x. Okay, and you know enough to realize that whenever you have a negative here and an exponent's odd, your answer is going to be negative. So let's go ahead and write f of negative x. So we get negative 5x to the 7th. And then this next one we get plus 6x cubed plus 2x. Okay, so that is f to the negative x. So what we're going to do is compare that with negative f of x. So if f of x is the top equation on the page, it's going to, a negative f of x then is going to be negative, and then we've got 5x to the 7th minus 6x cubed minus 2x. So we're just going to take our original equation and put a negative in front of it. That's what this means. F of x, we're going to put negative. So that equals, do this in black here, negative 5x to the 7th plus 6x cubed plus 2x. So negative f of x and f of negative x are the same. So therefore, our function is odd. If they weren't the same, and usually it's going to be a negative or a positive sign that's going to do that somewhere, you know, one of these signs are going to be different and makes it not the same, then it is not odd. Okay? So something to remember here. Number one is that a function does not have to be even or odd. Some are neither, and that's okay. So many functions are neither even nor odd because they're not symmetrical across the y-axis or the origin, and that's okay. And the other thing that's really, really important to remember is if one of them is even, it cannot also be odd. Or if it's odd, it's not going to be even. It's not going to be both even and odd. So one of the things that you want to do is if it's asking you if it's even or odd, and you find out trying it one time, or you try and it ends up being even, don't keep going to find out if it's also odd, because it's not. It's going to be one or the other. The only time that's going to be different is if we have f of x equals 0. But, you know, that's a rarity. So, it's going to be either even or odd. So, the first time you try one and you say, oh, wow, it's even, you know you're done. But let's say you try it and you find out it's not even, then you're going to have to try to find out if it's odd, because it could be odd. Okay? So, sometimes you'll have to do both. Check for it being even and odd. But if on the first try you find out that it works, well, then don't go on, because it's not going to happen for the second one. So, if it's even, it's not going to be odd. If it's odd, it's not going to be even. And it really doesn't have to be either, I guess, really. So, anyway, that is 1.7b as in boy.